Hello there, calculus students. Dr. John Schrage here. I hope everybody is well. I hope everybody's ready for our plans for this interesting adventure we're having in calculus right now. I think it's going to be fine. We're going to do our best to just stay on track as if we were in class. We're not going to try to have some modified deadlines where things aren't even due till you get back or something. I don't think calculus is the kind of class that's going to work very well in. Hopefully, by now you've gotten a copy of the related rates handout on Google Classroom. If you don't have that, this would be a good time to pause the video and do that. Alright, we're going to be working on some related rates problems. We're not going to move forward today. We're just going to do more of those kinds of problems. I'm actually going to break this up into several YouTube videos just because we might run out of battery on the camera, or my kids may come trotting through here because they can't stand me working on a class when they really want to tell me something about Curious George. So anyway, we'll break this up into like a playlist of YouTube videos for you. Alright, remember, we started talking before the last test about related rates, and related rates are always about when two variables are changing with respect to time, usually is the way we write it. So like how one variable is changing with respect to time should be related to how another variable or a different measure is changing with respect to time. And a classic example of that is what I have written up here, and it's the first little example that we have in the handout for you, and that is about thinking about the rate of change of global warming. In the problem I give you that we often say that the planet is warming at a rate of about 1 degree Celsius per century. Now per century is a little awkward of a unit to use for such a thing, so I changed 1 degree of Celsius per century to 1/100th of a degree Celsius per year. But that way we can say we'll use the variable C to be the change in to be the temperature of the Earth. Change in temperature in Celsius with respect to time will be 0.01. That is a rate. And what the problem is asking for is, what is the change of temperature in Fahrenheit with respect to time? So F will be a variable that's measuring the temperature of the Earth in Fahrenheit. Clearly, the temperature in Fahrenheit is related to the temperature in Celsius. The change in temperature in Fahrenheit should be related to the change in temperature in Celsius. And in case you don't know that formula off the top of the head, I give you in the handout that Fahrenheit is 9/5 Celsius plus 32. Alright, so how would we actually do this problem like I did there on the handout? Well, if we know that our variable F is equal to it's related to some Celsius in some way, what we can do is measure take the time rate of change of both sides, the derivative of both sides of the equation with respect to time. So the derivative of the left-hand side of the equation will be equal to the derivative of the right-hand side of the equation. Alright, well this is actually on the left-hand side, that's actually just what we're looking for. We're trying to solve for df dt, the change in temperature in Fahrenheit with respect to time. And over here, this will just be 9/5 times the derivative of c with respect to t. And the derivative of any constant is just 0. Well, actually though, the problem gave us this number. This number is 0.01. Right, that's the number I had up here for you. So, the answer is just 9/5 times 0.01, which if you actually work out the math is 0.018. So that would be your answer here. If you want to, that's in units of degrees Fahrenheit per year, which might be a little hard to think about. So if we multiplied that by 100, that would be 1.8 degrees Fahrenheit per century. That's a good estimate of how much the planet is actually warming. Our change in temperature in Fahrenheit with respect to time is about a little less than 2 degrees Fahrenheit per century. Alright, now that was not a very difficult problem because this derivative here was pretty easy. I mean, basically the only trick was remembering when I took that derivative of 9/5 c, okay, it's kind of like a little chain rule problem, I also have to have dc dt on the end here. That's the only trick there was to that problem. Now in the next video we'll move on and we'll look at that next related rates problem, which is not involving a story problem.